A little bit of a chat. So the internet has obviously grown, right? There is now billions and billions of devices connected to this thing. Every person, I think on average, has 3 to 4 devices connected to the internet. Talking phones, you're talking iPads, you're talking computers, TVs. Even my front doorbell is connected to the internet.
Oh, really?
Now, with more devices, with more data, what does that sort of attract? Evil, malicious entities, viruses, people that want to steal your stuff. Now, it is a rare day that you guys and I will be targeted. It is a rare day that someone will specifically point at Tommy and say, give me all your stuff, or I'm going to leak all this information about you onto the internet, or I'm going to start doing things to you. It doesn't happen. What does happen though, that malicious people or black hat hackers is actually like the global term for them. Okay? Does anyone know the difference between a black hat hacker and a white hat hacker?
White hat hackers try and find vulnerabilities and tell the server about it so they can fix them.
Yeah.
While black hat just uses it for malicious needs to tell somebody else how to
Yeah.
break into servers.
Exactly right, yeah. And the big thing about white hat hackers as well is they often do it as a hobby. It's like, I like hacking things, I like breaking into systems, but then they tell, as you just mentioned, they tell the company about it. This is what you have to fix. Sorry, Sam, do you want to jump in?
White hat hackers are usually in cybersecurity, and then they follow like a big role that I'm aware of is pen testing. Which
Yes.
is just like
Actually,
backdooring into websites and stuff.
and you've just absolutely touched on something. When I went to the Drone Nationals last term, the bloke I was racing with, his pilot name was Bear. Anyway, it turns out he works in cybersecurity in Canberra, I think. Yes, he's Canberra. And he said one of the biggest things they're actually pushing at the moment is not hacking software, it's not hacking operating systems or servers or whatever, it's social engineering. It is breaking the people that work in the systems. So we will touch on that. I will talk about social engineering and some examples of it. I've even got a video I love showing about that. Did you want to jump in, Tommy?
Yeah, how do you go on the drone racing?
I qualified as 72nd and I came out 53rd. So I could have done better, but I couldn't get my drone to get in the air in my last race. So if this is about drone racing,
How many people were in it?
about 100. Yeah. So I was about the middle of the pack. So I was pretty happy. So guys and gals, have a look at this for me. This is a little bit of a convoluted system here. Okay? But what you see here is this is a very simplistic version of what happens when your computer asks for a web page. And we're going to see this a lot as we go through. But if we have a look, so on the far left-hand side, there's us, desktop PC. We're browsing, we want to go to YouTube, we want to watch, daily dose of internet because we're feeling really sad that day and we want to feel sadder. So we go to our desktop PC, you crack open Google Chrome or whatever browser you use, type in youtube.com, and the first thing your PC does is talk to your modem, because your modem is what connects you to the internet. Everyone cool with that? Fantastic. Now your modem actually talks to a giant server somewhere in Sydney, maybe in Bathurst, somewhere else, and that connects you to your ISP, your Internet Service Provider. Is everyone okay with this so far?
Yes.
If I'm going too fast, let me know. Now, quick examples, you've got like BigPond, you've got Optus. I personally go with Internode, however they're a dying breed. What's another one? TVG? Dodo, I think, are another one. They're all Internet. Exactly. So your PC talks to the modem, which talks to your Internet Service Provider. Now, if your computer doesn't know the IP address to go to YouTube, the first thing is your ISP will contact a DNS, or it probably has a DNS, and it will return the IP address to you. And your computer goes, cool, now I know where to go. And then it will contact that IP address, which is YouTube server, all the way on the internet. You've got to go through probably a dozen, maybe 24 computers before you get to YouTube. Believe it. That's why sometimes loading a web page takes forever, because there's all this back and forth. Once your computer contacts YouTube servers, YouTube then goes, what do you want to view? Oh, you want to view the homepage of YouTube. Cool. Let me load up the trending videos. Let me load up your subscriptions. Let me load up some recommendations. And all of that comes from the web server database. Because it's a huge computer with lots of data in it, with all the videos, with all the information, with your account details. And the server will pull all those details from the database. It builds a web page for you. And then it starts sending it back through all those things. Doesn't that sound weird?
That is cool.
There's a lot of people involved, isn't there? Oh, Aiden's already picked up on what I'm getting at. I've actually simplified the crap out of this. As you can see in the top left there, I haven't shown you firewalls, network switches, cabling, DNS, connection hops, all sorts of things. What can go wrong, do you reckon?
Hackers.
You can intercept anywhere.
They can get a really big piece of really big scissors.
Really big scissors. We're back to the Cold War tactics.
Yeah,
Beautiful.
Yeah, they really.
At any point, someone can insert themselves. And these are called middle of the man attacks. Or man in the middle attacks. In the middle. And essentially that just means someone is just tapped into a connection and they're just listening to everything you do. Okay? And it's not hard for them to do this. They can just pretend to be a server in between your ISP and your web server. And they can just listen into everything you're doing. What happens if you're typing in your password? What happens if you're typing in your credit card details?
HTTPS. But
So now we're getting into the protection. But that's right. Sorry, Alexis, I've kept you waiting.
So I know that the web server database collects user data and everything, but do internet service providers also do that?
100%.
Like, do they keep a record of every, for example, you go to YouTube, not only does the database keep it, but the service provider also does?
Yep, the ISP will keep a record of everything that you access. Unfortunately, if you have a look through like the user agreement when you sign up for an ISP, it's pretty scary how much they actually track. The beauty is though, 99% of data that is sent over the internet these days is encrypted. So, and that's even for your ISP. So if you send your credit card details to eBay or whatever, the ISP can't just go, ooh, lovely credit card numbers. It's all scrambled and they will never be able to unscramble it. And they'll have a lot of protections in place as well. So we've got a lot of things that can go wrong, don't we, everybody? There's a lot of stuff that can go wrong in just asking for a web page. Okay, so this brings us to network security. Your stuff might be stolen, modified, taken, things like that. However, all the examples I've given you so far have been examples to do with just like a user opening up a web page, right? We're not just users in software engineering, what are we? We're programmers.
We're the people.
We are the devs. We are the ones responsible for everyone's private data. If you make a web page and that web page collects their username, their password, their address, maybe even their credit card details, I need you guys to think about how do you protect your users. Not your company, not your personal details, everyone who uses your app. Does everybody that makes an app or a website, do they care about security?
Yes.
not everyone, no. I don't.
99% of stolen passwords, and this is just a bullcrap figure I pull out of my butt, but a hell of a lot of passwords and accounts that are stolen is literally just because people go to random dodgy websites and it says sign in or make a new user account. So you sign in with the regular email and the regular password you use for every website. Oh look, it's stolen, it's now on the dark web and people are going to buy it. It doesn't take much. Okay? So, the other thing I want to quickly touch on,
I want to hear about this. Unless I trust that site.
VPNs don't protect you. I don't care how much all those goddamn ads on YouTube and podcasts will tell you they're going to protect you and they're going to keep your IP safe. They do jack shit. It's just another computer on top who's encrypting your already encrypted data. If you still go to a dodgy website on a VPN and you give that dodgy website your details, that dodgy website doesn't give a shit that you got a VPN. It's still stealing your data. Sorry, Alexis.
Oh, I was just going to ask what you already
I want to watch
said.
British Netflix stuff.
Fair enough.
That's a good
That's got
time.
nothing to do with security. But
What if I want to torrent without getting network throttle, so I need my VPN?
Theoretically.
This would be a perfect time for our sponsors.
Sam?
Stuff, Sean.
Okay. Because just
You thought this.
I hate that VPNs are preying on regular people, and the biggest thing they push is that they're going to encrypt your data. Well, every single website you go to these days has got encryption on it. And that just means the messages that you send and the ones you received have got some kind of encryption.
So the
You can still go to dodgy websites that are secure. But when they get your data on the other end and they unpack it, they could just store it as plain words. Like if they don't give a shit, they're still not going to give a shit if it's secure. Sorry, keep going, Alexis.
So, would you say that 99% of sites are now secure?
Yeah. Yeah.
Is
No.
that a legal thing?
That's
or-
HTTPS.
No, it's just, it was pushed by Google. So a couple of years ago, Google announced that any website you went to that didn't use HTTPS, they were going to put a giant unsecure
It's
on
so
the address
good.
bar. And that pushed everybody to get SSL and implement security. And I'll talk about that in more detail.
I love
See?
it. So a VPN is basically just two-factor encryption.
In some respect, yeah, it's encrypting or encrypting data, but what it's doing is you're no longer connecting on a direct route. You're redirecting your signal to somewhere else and it's bouncing back. So it looks like you're in a completely different part of the world. So it's true, it will protect your location data, that is true. But in terms of your data itself, not really, no. Dodgy websites are still going to be dodgy, no matter what. So just quickly through, why or how can they do this? Sorry, I'll get to the why after. How do they do this? Okay, we already talked about man-in-the-middle attacks, okay? But there's some big ones these days. So SQL injection apparently is like the #1 type of attack that black hat hackers will do. We're going to learn SQL, so you guys will learn more about what the hell that is. But essentially, SQL is what we use to get data from databases. It's what we use to store data from databases. And literally, oh, hold on. Let's see if I can find it. This is only going to be funny for people who know SQL. XKCD. Johnny drop tables. Oh, that's so tiny. Rabbit. Oh, I misspelled that.
You that's sound effect.
Here we go. Okay. All right, so this is an example of SQL injection. The idea is that, right there, there's his name, right, Robert?
Yeah.
Okay? But then they've added something extra. So in SQL, if you put an apostrophe, that's the end of a string. If you put a bracket, that's the end of a command. If you put a semicolon, that's the end, bracket's the end of the brackets. Semicolon's the end of the command. And then another command you can do is drop. And then you can specify what in the database you want to drop. Well, they want to drop the table called students. And this little double dash here basically means if there's anything on the end of it, ignore it. So what that effectively would do, if somebody was entering Robert's details on the school database, this would delete every single student in the school. Is that funny? It's funny, man. I like it. Little Johnny drop tables. So that is SQL injection. It's literally adding a command into a field on a web page. So literally like on a Google search or on a first name, last name or a password field, you put an SQL command on the end. And if the website hasn't put protection in place, it's gone.
Is there any famous cases of this happening?
I reckon there probably is, but I don't have any examples off the top of my head. We'll have a look afterwards. Cross-site scripting is another big one. So cross-site scripting is the idea that you've got a genuine website that you are using. Okay, let's say, bad example, maybe the department's portal. Okay, and what the hackers might do is find some way of modifying the source code of that page to put their own script on that runs on a completely different server or different site. And it's collecting your passwords and your usernames and your activity and everything like that. So it's known as cross-site scripting because it's a script on another site that's running on a genuine web page. Okay, we're actually going to touch on that a fair bit. DNS spoofing, I think I talked about this with some people last time. The idea that you're a DNS server, Ben's computer connects to mine and says, hey, where's youtube.com? And I go, oh, this is totally youtube.com. You should go to this one. And Ben's computer goes, okay, and goes to a fake YouTube and steals all his data. Okay? Next one down here, using known exploits. The great thing about open source software is they often have their Git commits, which has their change logs, which has the bugs and the exploits for the previous versions. So if Marley's decided to be a bit of a silly bugger one day, and he goes, I wonder what server Microsoft are using, and he goes out and he finds out they're using an outdated version of some software. Then he goes to look up the change logs for the next version. He goes, oh, there's an exploit. I can use that. And he literally has an exploit in his back pocket straight away.
Oh, you know me.
Exactly. Phishing? Does anyone know what phishing is?
It's me when I look for the yummy little fishes in people's emails.
Ah, in emails. So what about the emails?
You see, I pretend to be Big John Google, and I send them an email saying somebody is trying to get in. Click this link, and we will reset it for you. But in reality, I'm not John Google.
I feel like the issue I have is when actual proper companies do that.
Oh, yeah.
Like I think they should be like, hey, by the way, we've noticed something wrong. Here's the phone number. Ring us.
Yeah.
So you can talk to you about it.
Alright, Alexis, is that a head up?
I know you can get the passwords and then you can sell the passwords and then everyone can have your account details. But at the end of the day, what are you going to do with some random person's
Call of Duty account. You know what's gonna happen?
Like what, if it's not.
I'll literally talk about that in the next slide. What can we do with people's personal details? Great question. Alright, guys. Stay with me. Last couple, DDoS attacks. I've skipped one, I'll come back to it. Distributed denial of service attacks, basically taking down servers by just spamming them with connections or messages or requests. And it overwhelms the servers, they crash. Okay, and in the interim, that might open up exploits in a server or a system. Next one. This one recently was very popularized with the recent, what's their name called? Pokemon developers? No, not Niantic. Not Pokemon Go developers.
Game Freak.
Game Freak, thank you. Yeah, so Game Freak recently, somebody got into their system, they installed malware, and there's a huge dump of all their source code and all their lore currently being leaked
That's
on
why I
the
don't
internet.
listen to bad video games.
It was a ditto, it wasn't my fault.
Alright, there's one type of attack that I did not touch on, and I want to touch on it a little bit, and there's slides for it, but we'll get there, is social engineering. It is the idea that you're not attacking the computer, you're not attacking the software or the technology, you're attacking the person. And I've seen a really cool YouTube video, and I was going to show it to you, but I might skip over it just purely because I'm recording, and you guys can look it up in your own time. But it is a social engineer hacker, and what she did is she called up a phone company. And she got her other phone out and she started playing audio of a baby crying in the background. And she's like, and then she started putting on huffy voice, like a really frantic, oh my God, I'm in a rush, really. And so she's like, oh, hi, I really want to talk about, my husband's phone account details. Oh, shh, calming the fake baby. And it's like, hey, I'm such and such, can I please have, the details? Oh, you can't give it, oh, sorry, oh God, I'm in such a rush. It just put it on massively, just layered it on and on and on and on. And eventually, after like a 5-minute phone call, she hangs up the phone and goes, here's your password, to the interviewer. Wow. And so, social engineering is a big thing. And that guy I was talking about at the drone flying bear, he said this is all they're doing at the moment, is just social engineering and trying to train people up around that stuff. I'll come back to that in a second, sorry, Zach. I just want to move forward. Because I want to answer Alexis's question is, what do they gain from it? You can steal these passwords and these accounts and these details. What do you get? Well, the first one is probably the simplest one, that's identity theft, okay? The idea that if I get enough details about someone, I can start pretending to be them. I can start, if I even get enough things, I can start signing up for small loans in their name. And then all of a sudden I'm making money out of their personal details, okay? I can even blackmail. Now this is targeted and it is a rare thing, but if they start getting some really bad stuff, like maybe they've got nudes, maybe they've got really personal details about these people, they will go to you and they say, hey, this is what I got. What are you going to do about it? Oh, you're not going to pay me the 500 bitcoins. Well, guess what's going to happen? That kind of stuff. Next one, stolen credit cards is a big one. There's millions of credit card numbers being sent over the internet probably every second. It's not that hard to steal one or two of those ones. Fake social media posts pushing things like the Trump agenda, all that kind of stuff. I'm not shooting on Trump here, but there is proof that there was a bot network from Russia pushing Trump propaganda on Facebook during those elections. Okay, probably even these ones, but I won't get into that. Creating bot accounts, okay, stealing people's accounts. because they're legit and they've got history behind them, they've got posts, they've got history, essentially. And then they steal Tommy's account, they turn him into a bot account, and all of a sudden it's harder for Google and everybody in Facebook to shut them down because Tommy's account was legit before that. It's just Tommy might have had a change of heart and he really, really loves Trump now.
Is this like the
For
Chinese
whatever
phone
reason.
farms where they're creating a bunch of accounts to sway the election without actually voting?
I
Is this
probably would believe that. I couldn't tell you one way or the other, sorry. Next one, stealing friends' personal detail. When I say that, in other words, they're not stealing their own friends, they're stealing your friends, okay? If they get into your Facebook account, well, all of a sudden they've now got access to all your friends' accounts, their photos, their posts, their personal preferences, all that kind of stuff. And the big one, selling it on the dark web. Big time. Now, if you really want to check if you have been hacked, I've done this with my classes in the past, but Have I Been Pwned is a great website. It's actually developed by an Australian, just so you know. You simply chuck in your email address.
This I probably have been fucked.
Hello?
Oh, they have the things.
Hey. Okay. I have been pwned 7 times. So that means my personal details have been stolen and put onto the dark web. Because what the developer Have I Been Pwned does,
I'm playing.
guys, I can't talk over screaming. So what's the developer Have I Been Pwned does is he goes to the dark web and he buys packages of email addresses and passwords, and then he puts it in his database for people to search and see if he'll appear on those lists. So I appear on Canvas Hack, Geeked In, don't remember that, Gravatar, Lumen FPV, Nitro, Trello, and Unreal Engine. So, now, there's one that's a little bit touchy, and this one you'll probably think, oh, I don't want to do this, but he's got now a password section. And what he's done with this, you put in your password and it will tell you how often it might appear on these lists. Now, before you go, he's just stealing my password. What he does is he encrypts your password and then he chunks it up and he only takes like the first chunk from memory and then he compares that against all the other first chunks in his database. So he doesn't actually take your password and compare it against stuff. So if I just type in,
It's encrypted.
let's do QWERTY, hit pwned, and it's been seen 10,700,000 times.
Oh my god, dude.
So, something to have a go at because it happens. Your stuff is probably going to be on the dark web somewhere.
Wait, how many million times?
It's going to be in the camera. So, just quick. What can you guys do as a developer? What can you do to protect your apps and the data that you are getting from your users? Okay? Now, before we do that, there's a couple of concepts I need you to go through and I need you to learn. The first one is plain text. It is literally how it sounds. We've got cipher text, encryption algorithms, encryption keys, SSL, authorization, authentication, hash values, and digital signatures. And I want to touch on each one really quickly. And then you guys can jump in. The exercise this time around is really based around activities rather than just knowledge. So firstly, plain text. It's exactly what it sounds like. Plain text is just raw letters and numbers, okay? Typically, most of your data that you put into systems, like your name, your username, your email, address, all this stuff is stored in plain text. And the reason for that we don't encrypt it is because every time you encrypt data, you are adding processing time. So like, for example, if Will signed up to my website and I encrypt his name, anytime I just want to say, hi William, on the front of the webpage, I've got to decrypt that data and send it back. And that just takes precious time and resources and power and all that kind of stuff. So we don't tend to encrypt things that don't need it. Credit card numbers, passwords, sensitive data must be encrypted in some sort of way. Fun story for you. Meta was recently fined $102 million for doing just that. They didn't mean to. It wasn't on purpose, but they accidentally, on a log, were putting people's plain password text on the log. $102 million. For us, we're like, holy shit. For Meta, that's like, okay, righto. See you later. Now, cipher text. Obviously, we do not want to store things in plain text. You want to store secure things in encrypted or what you call ciphertext. So if you take regular old words like dog and you jumble them up in some fashion, that is known as a ciphertext out the other end. Everyone cool with that so far? Very beautiful. So anytime you have secure data, you want to make sure it's stored as ciphertext, not in plain, because otherwise you are screwed and you're going to get sued just like Meta did then. Okay? Now, how do we achieve this ciphertext? There are so many different ways to achieve ciphertext. All right? We'll touch on a couple. The first one is called encryption algorithms. And it's probably the one you've heard the most, encryption, right? Encryption is like the silver bullet, right? You take secure data, you feed it through something, and out pops encrypted data or ciphertext. And what you're doing is you're feeding them through encryption algorithms. And these algorithms have been made by mathematicians oodles of times smarter than me, and their job is purely just to go, how can we scramble this data enough that no one can ever read it, and how do we get it so we can unscramble the data? That's the key with encrypted data, by the way, boys and girls. We not only have to be able to scramble it, we have to be able to unscramble it. Who's heard of the Enigma machine? Ooh, nice. A few people have. If you have not seen the Enigma machine, used in World War II by the Germans, famous, amazing machine that was broken by the British. Actually, it was the Swedes, I think, that originally broke it. Then it was the British who automated it with the invention of a lovely thing called the computer. But essentially, yeah, it was de-encryptable data, essentially. So boys and girls, if you look at over here, we've got the word hello. We put it through an encryption algorithm, and out becomes gobbledygook. That is ciphertext. Then, in order for us to read it, we need to put it back through that algorithm, reverse it, and we get back to the original message. Okay? If we can't reverse it, it's rubbish at that point. We have a couple of different algorithms over here. Triple Data Encryption Standard, DES, we don't use it anymore. Okay? We have an advanced encryption algorithm, used a lot, and then the top of the line, the reversed Shamir-Adelman security, RSA, known for the three people who invented it. Sound pretty good? I'm never going to ask you what RSA stands for. Yes? No.
If we're using specific types of encryption, shouldn't it be easier to D?
Ooh, love that question, and I'm going to answer that soon. I'll come back to that. Lex?
How are data breaches actually dealt with to fix them? Is there a way to scrapple the data off the internet, or is it just
Once it's out there, it's out there.
have all of these companies tried to do anything?
The biggest thing these companies can do is just track down the hole or the issue that caused the data breach in the first place, and then just go try and fix it. And if they'll probably go over all their data and say, all right, what was encrypted, what was not encrypted, and they will try and figure out, okay, we need to batten down the hatch on this database, this one's okay, all that kind of stuff. To answer Harry's question, if we're all using the same encryption algorithm, how do we make sure it's all protected then? Okay? I should be able to decrypt any RSA message because I have access to that algorithm. Well, it all comes down to encryption keys. Okay? The idea that you have a special message that you put in the algorithm that scrambles it even further and makes it worse. So even if you understand how RSA works on the ground level theoretically, if you don't have a key, you're screwed. You cannot decrypt it. Does that make sense?
Yes.
So far? Now, I love these boards sometimes. Okay, now the way keys work, you actually have two different types of keys, okay? Think of them a little bit like your password. You can't get into your account until you've typed in the password, right?
Yep.
That's an encryption key, essentially. There are two types. There are symmetric keys and there is asymmetric keys. The way symmetric keys work is that, let's say Ben and I are trying to communicate. I am sending something to Ben, okay? Let's consider Ben the host, I'm the client. Ben's like the powerful person in this situation, if you want to think of it like that. When I send a message to Ben, I first of all grab my message and I encrypt it using my key. I then send that message to Ben. Ben has the exact same key so he can unscramble the message and there's the original data. Is that okay so far? So that is symmetric keys. However, what's the problem with that, do you reckon?
Man in the middle attacks for sharing the key.
If anybody, I have to get the key to Ben in the first place, don't I? For him to be able to decrypt the message. If anybody gets that key, we're screwed, okay? Ben and I can communicate, and if there's a man in the middle, they're stealing all our data, they'll probably have the key and they can just decrypt it willy-nilly using the exact same encryption. Then, asymmetrical keys is where we introduce the concept of a public key and a private key. This is by far the most popular method, as you can imagine. Public key is just that. Anyone can have it. Because all the public key does is the encryption. I take my data and I get my public key and I share them, jump them together in the RSA algorithm, blah, 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 it all gets scrambled up and I send it off to Ben. Okay, but to decrypt that message, Ben has the private key. And only Ben has that private key. He doesn't have to share it with me. He doesn't have to share it with anyone. He just keeps that private key. Okay? He then decrypts that data I sent him, with the public key that is, and then he can see it. How's that sound?
Yeah.
That's a much better solution, isn't it? Than just, here's one key that does everything. Well, now you've got two. One can encrypt. You cannot decrypt using the public key. You can only encrypt using it. Such a clever little system. Again, people much smarter than me have invented this system. Okay. So, moving along quickly. SSL, anytime you're using HTTPS and you see that lovely lock on Google Chrome or Edge or whatever you're using, you have connected using HTTPS using an SSL connection or secure sockets layer. Alright? And all that does is it introduces encryption to your connection. There's a good chance it's using AES or RSA. And it will be using public-private keys in order to do that. So that way you know the data, even if it gets grabbed at any point, it's all good. Alright, next one. You guys are familiar with this?
Yep.
Authentication. Yeah. You log in every time you walk into my classroom, don't you? You go to Google and sometimes you have to log in again. You open up your phone, you have to log in there as well. That is authentication, right? Okay? The simplest way that we all know and love, in fact, I don't love it, I hate it, email and password.
Why do you hate it?
I hate it because it's exploitable.
Yeah.
It's extremely exploitable. Single sign-on. Who's got multi-factor authentication? That's actually a different one again, that's down the bottom. Hands up if you use multi-factor on your Google accounts.
I don't know.
Hands up if you use multi-factor on your game consoles.
Console baby, I think.
Steam's multi-factor.
Steam Guard is multi-factor.
I have Steam Guard. I don't have any.
Beautiful. So, guys and gals,
Oh my god.
if you want the textbook definition of authentication, it's essentially verifying someone is who they say they are. That's what it is. So we can do that a bunch of different ways. Phones have really pushed these in the last couple of years. Biometric, facial scan, fingerprints, those kind of things. And passkey is a brand new one that Google is pushing out big time. Okay, if you haven't looked at passkey, I'd suggest go and do it. Single sign-on, the school uses this a bit. You log into the school computer, right? Username, password. Theoretically, it stores those details, and then when you go to Google or you go to the student portal, it uses those details again to keep you logged in. And that's called single sign-on, because you sign in once and you sign into multiple things. Okay? There's also, when you go to websites and it says log in with Google. I would recommend you do that 99% of the time too, if you have to. Now, this is the bit that might confuse people. Authorization. So we just talked about authentication. Authorization is essentially what is your permissions. What are you allowed to and what are you not allowed to do? And in the terms of websites, there's a lot of things that we can restrict. We can restrict what they can see, what files they can open, what actions they can perform, like creating data, deleting data, viewing data, and what settings they can have access to. Okay? So authorization is not the same as authentication. Authentication is saying, this is Dobby, I believe it's him, because he typed in the right username and password. Authorization is Dobby tries to go to the admin page to delete everything and I go, no. That would be authorization. All right, we're almost there, everybody. 2 more to go. I promise this will be quite quick. Now, hash values. Goddamn popular, you don't even know about it probably. Hands up if you've heard of a hash value. Nothing to do with hash browns. 1, 2, 3. All right. A hash value is a really simple concept. It's the idea that it's an algorithm or a function, depending on what you want to call it. There's the function in the middle there. You feed it whatever you want. Feed it text, feed it a picture, feed it a file, whatever, doesn't matter. It always spits out a string of characters the same length at the other end. Bit jumbled depending on what you put in. So if I put in the word dog, out pops 32 characters. I put in the word cat, out pops 32 characters, they'll be different to dog. Okay, I put in the complete works of Shakespeare, out pops 32 characters, and they'll be different again, because there's so many different combinations. It's hexadecimal, if you want to get technical. So this is really goddamn handy, because I can, let's say I'm putting up my game, it is 50 gigabytes in size, and when Zach downloads it, I want to make sure he gets the whole thing, it hasn't corrupted along the way. So what I do is I put my 50 gigabyte file through a hashing function and make 32 characters at the end. And I say, hey Zach, put your 50 gigabytes through this hash and you should get this exact same 32. Does that make sense, everyone?
Yep.
Somewhat. That way Zach goes, all right, download it through the hashing function. Oh look, I've got the same things. I know it's worked. It's perfect. The most common hashing functions, you might have heard of MD5. Please don't ever use MD5.
What happened to it?
It's reversible.
Oh, fuck.
SHA1 is the one you want to use these days.
I'm gonna write that.
Use SHA1. Now, why am I teaching you about this? Because when you guys get a password, you do not, for the love of God, encrypt and store that password. Because the biggest problem with encryption is, with the right people and the right tools, it's reversible. I can decrypt. The idea of a hashing function is that all I can see is the end result of the hashing algorithm. I will only ever store a hashed password.
Hashed, not encrypted.
Not encrypted. Because if you use SHA1, it's not reversible. You can't go back to the original. However, when Brody tries to log in and he types in dog for his password, I pop it through the hash function. I then compare dog that he just typed into what's stored in my database. And if they match, he's typed in the right thing. Okay? Yeah, sorry, let's go for it.
On the site you just give us to check out, how do they know, how do they get an email and immediately connect it to everything you've ever signed up to?
They literally just try it.
For everything?
Yep.
Wow. That's very fast.
So like if you just, probably not immediately, but pretty damn quick, I reckon. So like let's say your email is alexis@awesome.com or whatever, and your password is dog, and that leaks from one website, well, they would just take that email and password and just go, I'll try it here. And if they get any hits, then success. They've stolen more accounts. So yeah, hash values, really important, guys. Last one. Last thing. Digital signatures. This is a little bit like a hash value. Hash values are to make sure the files or the data I get is the same. And digital signatures do this. However, it also provides authenticity. Okay? It makes sure that the data I receive is good and it's legit. Okay? Now that's it. I'm said and done, guys. Thank you for listening. I really appreciate it.